Hey there, sports fans. Today we're going to talk about radical equations. What are they and how do you solve them? So we're going to I'm going to show examples of two different types of radical equations. Some of them you have to check both solutions, some of them you do not. So I'm going to explain that in this video. So today we're talking about radical equations, not to be confused with rational. I write the word rational out. But a rational equation is one that has fractions. So we're not looking into those types of equations. A radical, this is a radical. A radical has a square root symbol, like this. So a radical equation looks like this. So when you have an equation that just says, say, switch colors again, x equals 2. The one and only one solution to this is 2, because 2 equals 2. But sometimes we'll see an equation like this that says x squared equals 4. So if I were to take the square root of both sides of this, I would end up with x equals plus or minus 2. That's because plus 2 times plus 2 equals 4, and negative 2 times negative 2 is equal to 4. So we're going to look at ones that are a little bit more complicated. In fact, we're going to show that if both sides of an equation are squared, like right here, I took the square root of both sides. But if you square both sides of an equation, then all the solutions of the original equation, if they exist, are also solutions to the resulting equation. But the reverse is not true. Okay, so for instance, taking the square root of both sides. So for all of the solutions of the resulting equations that we had to square both sides, everything is going to be true. So let's get started. So let's look at our first example. We have the square root of x minus 2 plus 3 equals 0. So the first goal of these radical equations is to get the radical by itself so that you can square both sides and solve, or attempt to solve. So the first thing I would do is add negative 3 on each side. Just right away you can tell, is the square root of any number ever going to be negative? The answer is no, but let's go through this just to see. So go ahead and square both sides. That gets rid of our radical on the left-hand side. And if you square the left-hand side, you also have to square the right-hand side. So that leaves us with x minus 2 equals 9. Because negative 3 times negative 3 is positive 9. So let's go ahead and solve this for x. I add 2 on each side. I end up with x equals 11. So it looks like it's a good solution. However, let's come back up here and substitute. So when I substitute 11 in place of x, 11 minus 2 plus 3, does that equal 0? Well, 11 minus 2 is 9 plus 3. And does that equal 0? And the square root of 9 right here is 3. And 3 plus 3 obviously does not equal 0. 6 is not equal to 0. Therefore, x equals 11 is not a solution. And hopefully that makes sense to you from the very outset. When I had to add negative 3 or subtract 3 on each side, you can never take the square root of a number and get a negative. All right? Not with real numbers. So that was kind of a giveaway for that one. So let's look at a second example. So here's a second example. Notice that I'm starting with a minus 6 instead of a plus 3. So when I go ahead and I add 6 on each side, I'm going to have the square root of x minus 2 equals 6. So now this is a positive number on the right-hand side. So can I take the square root of a number and have it be positive? The answer is yes. So let's continue. Let's square both sides of our equation. So that is the first step. And then let's go ahead and square root of the number squared is the number, x minus 2. And 6 squared equals 36. So add 2 on each side. X is got to be 38. So again, we'll come back up here and we'll substitute. Is 38 minus 2, square root of that, minus 6, is it indeed equal to 0? Well, I have 36, square root 36, minus 6, is that equal to 0? And 6 minus 6, yes, that is equal to 0. So I have 6 minus 6 equals 0. So 0 does indeed equal 0. So that one does check out. So x equals 38 is a solution that works. Let's go on to a third example. So here is a third example. X squared plus 9. That's my radicand. So it's the square root of x squared plus 9 minus 5 equals 0. So the first thing I want to do is add 5 on each side. We want to isolate the radical. So x squared plus 9 and the radical equals 5. So now this is where we say I have to undo that radical. So I'm going to square both sides of this equation. So that gives us x squared plus 9 is equal to 25 because 5 times 5 squared is 25. Then go ahead and subtract 9 on each side, or you could subtract 25 on each side. I would probably be inclined to subtract 9 on each side and get x squared equals 16. So now I'm going to take the square root of each side. And when I take the square root of 16, I have to get a plus or minus 4. The other way to have done this would have been to say subtract 25 on each side. You'd get x squared minus 16 equals 0. And then that would factor into x plus 4 and x minus 4 equals 0. So you'd have x equals negative 4, x equals positive 4. For me, anyway, this seems like a few more steps, but it's definitely a way to do it. Versus just take the square root of both sides and you get your x equals plus or minus 4 here. Now, we do have two solutions, so it's important to check them. But we started off by squaring both sides of the equation, so these should both work. So let's go ahead and check them. I'll check a positive 4 first. So here is my check. I had x squared plus 9 it was. Is that equal to 5? So we'll start with a 4, positive 4. So that gives us 16. When I square the 4, 16 plus 9. Still taking the square root. Is that equal to 5? Well, yeah, the square root of 25, that does equal 5. So I'd end up with 5 equals 5. Check. Let me give a better check than that. Check. All right, the other one that we want to try and check is the square root of negative 4. So square root of x squared plus 9 equals 5. Only this time we're going to use the negative 4 here. Well, as it turns out, negative 4 times negative 4 is 16. So I still end up with the square root of 16 plus 9 equals 5. That's a bad 5. So the square root of 25 equals 5. is a solution. So this shows that both positive 4 and negative 4 are indeed solutions. So sometimes you have to check those both, but we knew that they were both going to work out because we said at the beginning, when you square both sides of an equation, you know that both solutions will work. So here's an interesting looking equation. Square root of x minus 1 minus 3 plus x equals 0. So I'm going to have to move this stuff to the other side, and it won't be a radical. So there's a good chance that I'm going to get two solutions and only one will work. So I'm going to try, let's see, 3 minus x on the right-hand side. So we want to get rid of this radical, and we know that to do that, you have to square that. And if you square the left-hand side, you have to square the right-hand side. Now, here's a difference. I'm squaring this, and it's not a radical. So let's go ahead and finish this off, and we'll do the check. All right, so back to white. X minus 1 equals, I'm going to have to FOIL this. All right, so I just created a quadratic equation where there wasn't one. So when I FOIL 3 minus x, we get 9. First times first is 9. Inners and outers add up to minus 6x. And negative x times negative x, that's our positive x right here. So let's go ahead and put everything on one side of the equation. Let's see, I'm probably going to keep it on the right-hand side right now, just because my x squared term is positive. I'm going to subtract this x on each side, which is going to end up giving me a negative 7x. And then I'm going to add this 1 on each side. So 9 plus 1 would leave us with a 10. And then that will be equal to 0 on the left-hand side. So let's go ahead and set this up as a factoring problem. So do we know factors of 10? Factors of 10 add up to 7. Yepper, we do. They are 5 and 2. So negative 5 times negative 2 is positive 10. Negative 5 plus negative 2 is negative 7. So if these are all equal to 0, we're going to use the zero product property. If this times that equals 0, this is 0 or that is 0. So if this is 0, then x is equal to 5. But if that is 0, then x is equal to 2. So now let's go back and to the beginning and check these out. So we're going to check a 5 and a 2. So coming back up to this equation. So the square root of x plus 1 minus 3 on the outside plus x, is that equal to 0? So the first one I'm going to check is, I guess I'll check the 5. So 5 and 5 go in here. So I have the, oh goodness gracious, the square root of 6. Let's see. Oh, that's a minus. No wonder. Let me fix that just real quick. Just a happy little accident there. So that becomes a minus. So this would be the square root of 4 minus 3 plus 5. Is it equal to 0? So the square root of 4 is 2. We're going with the principal roots here because we're checking. So 2 minus 3, that's negative 1, plus 5, is it equal to 0? I guess I could keep putting my parenthesis up here. Is 4 equal to 0? The answer is no, it is not. So we were checking the 5. That means x equals 5 is not a solution. So the other one must be a solution. So let's go back and check that. So we have the square root of x minus 1 minus 3 on the outside plus x, and we want to see is it equal to 0. So the second one that we're checking is the 2. So does the 2 work? And it better work, because when I take the square root of 1 minus 3 plus 2, it's looking like we're going to get a 0, because 1 minus 3 plus 2 equals 0. Yes, this is negative 1. I'm sorry, that is negative 2 plus 2. And yepper, sure enough, that equals 0. So that checks out. So there's an example where when you check, they don't both work. And the reason one of them didn't was because that we squared something that was not a radical. If you're squaring radicals on both sides, it's going to work. This one did not. So let's look at a fifth and final example. All right, so here's an example where we have a radical on the left-hand side and a radical on the right-hand side. So 2x minus 3 is a radicand, so square root of 2x minus 3 equals square root of x plus 2. So just like before, we're going to get rid of these square root symbols, these radicals, by squaring both sides. So the square root of a number squared is the number, and the square root of a number squared is the number. So let's put I'm going to move this 3 over here. 2x minus x is x. I'm going to move this 3 over here. 2 plus 3 is 5. So x equals 5. That's the only solution we come up with, so it kind of has to work. But let's go back and check it just to make sure. So here's our check. I don't always write check in, but let's call this a check. 2x minus 3 equals x plus, or I should say square root of x plus 2. So let's substitute square root of 2 times 5 minus 3. Is that equal to the square root of 5 plus 2 minus 3? Well, let's double check this. We have multiply that. Square root of 10 minus 3. Is that equal to the square root of, what's 5 plus 2? 7. And looks like 10 minus 3, that's radical 7. So radical 7 does indeed equal radical 7. So that works out. So that is the check. All right, hopefully you got something out of that. Go ahead, hit the like button. If you have any questions, please enter them down in the comments below, because that helps me help you. All right, talk to you next time. Okay, I hope everybody liked those examples. Please go ahead and hit the like button. Also, make sure you subscribe so you don't miss out on any of the new content that I put out there. Summer is coming up, so there's going to be a lot more that's getting added soon.